Ah, yes, we've begun. Um, hopefully the right microphone is working. Yeah, here's this one. Anyway, I'm gonna bother looking it up. So just wait for the other thing to start. You have to wait so the chat thing and the other thing will work and blah 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 blah. Okay, so that appears to have happened, and I figured I'll do some comments. I was going to probably best to do that in a video, explaining this piece of paper, the whole polarization thing. Um, and that's really the only thing being exchanged. Um, as strange as that sounds, the only energy is manifested into something you call energy is through the conversion of polarization, the collection of it. And that's what makes the force substantial to something that is material. Matter is sensitive to polarization of the quanta coming at it. Anyway, that's for another time. Like I said, I'll do some comments. The really obnoxious, as it turns out, um, Numbly Numb has just proven himself the troll that I, kind of suspected always that he was from the beginning when he was doing all this whatever Wikipedia correction officer or something. And he was often wrong. He's correcting people and yet he's wrong. And I found that pretty obnoxious back on the old Inmendum channel. And then he came over here and is, played the game like he agrees with the stuff I'm saying and blah, blah, blah. And now because I don't agree with his conspiracy theories, I'm wrong and my theory's wrong. And it's been proven by the very NASA scientists now he's citing, the very ones he mocked, previously. This is just such duplicity that, it's just disgusting. Human beings do not, if there's an opportunity for human beings to disappoint me, they do it. Bravo. But yeah, it's a wayward horizon integrity school of shit crap he must have gone to. Yeah, you might as well, go troll Wikipedia pages. An asshole. Censor the internet for us all. Stupid little cunt. Anyway, so yes, a couple of comments by him. The most recent one wasn't very long. What the hell did he say? I forget now, but yeah, it was some kind of snarkyism. Just not related to the videos, which is really irritating. Oh yeah. He was apparently stuck his foot in my mouth or something in Piro's room, but I couldn't find that anywhere. I mean, I wasn't going to, I'm not playing a 7-hour crappy Piro video. And the only part I saw Numbly, and he wasn't talking. They were talking about the Iraqi war, so I don't know how I could have come up in that subject. So regardless, just useless troll. So I guess I'll just get his comment. There's a couple of them. They're just stupid. One. Well, let me go back to the. I will go back to. You know. Oh yeah. So this is the one on NASA. So yeah, I'll read that one. What the hell is this comment? It's got. He followed up his own comment. Oh yeah, right. I'm gonna pay any attention to you, you little troll. Oh, you really have some kind of bizarre expectations. Um, so anyway, have you heard about the new reactionless propulsion system from NASA has confirmed actually works? Yes, sure it does. Looks like it's time to say goodbye to Newton's law of motion. So now all of a sudden the physics he was arguing was bullshit. The dark matter, all that crap invented by all these assholes. All of a sudden they're brilliant. They know what the fuck they're talking about. I mean, M drive works just like any other engine. Well, if it's any other engine, then it takes fuel. Author of the paper told Mail Online, its fuel is the input photons at microwave lengths. Well, guess what? That's a fuel. Yes. Okay. And again, it's um, how much energy do you think is in it? Microwaves don't go through matter, obviously. They react to many forms of matter. So if they were strong enough to do something propulsion wise, they'd be moving us. The researchers suggest that photons coming out of the machine interfere with each other so that the overall effect seems as if nothing is there. Oh, these are quotes. Yeah, right. Certainly. In the cavity, the input photons will bounce back and forth, and invariably some of them will interfere completely destructively. So we're back to two slit nonsense almost. So what, this is what you're endorsing, you idiot? And you're expecting me to waste my time on this subject? I don't think so. Let's go see their perpetual motion machine. So yeah, let's see them build one. Fuck you, you idiot. This means the inertia of photons inside the cavity change as they bounce back and forth. To conserve momentum, they are forced to generate thrust. Yes, I'm sure. If you accept these results as genuine, then you also must accept that your theory has been falsified and drop it immediately. So listen to this crap. I should drop my theory that explains inertia, magnetism, time dilation. Right, I should drop it on Numbly Num's advice. Well, look, if this is going to be your attitude, I'm not reading the rest of your post. Well, he's following up with this crap like I give a fuck about this shit. Go ahead, show me the perpetual motion machine. Okay, that doesn't sound like something that's really going to happen, jackass. Yeah, not even close. I can go look up my own physics to talk about. I don't need you to tell me what I have to talk about, fuckhead. So yes, I'm deleting it without rating it. So fuck off. God, what a cunt. So here's the more obvious numbly numb bullshit. Okay. The solar systems are not flat. The plane of a topic is not a disk. The sun and the planets are moving through space on a linear trajectory, so the planets spiral around it, creating elliptical orbits. The distinction matters because rotational motion is not the same thing as helical motion. It doesn't matter. The solar system's flat, and for all intents and purposes, the only forces acting on the planets are the sun's forces, not the galaxy's forces, not the entire universe's forces. They're not really relevant. So you're just being a stupid cunt. By his idiotic theory, okay, this would mean that you couldn't say galaxies are flat. These galaxies are moving within clusters, and therefore somehow their motion isn't flat. It's flat, asshole, and it's over a period of time, and that's the important factor, is time. So their elliptical motion is much slower than their flat motion in the spiral, so it doesn't add up. It's bullshit. You're an idiot, and you're a cunt. All right. So anyway, I posted the first Google search on flat solar system, and it just says, the solar system is indeed very flat. The orbits of all the planets are within a few degrees of the same plane. And blah, 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 blah. And then he says, I agree that the plane of the elliptic is narrow, but the plane of the elliptic and the solar system are not the same thing. Well, I'm sorry. If I'm talking about the solar system, that's what I'm talking about. I'm not talking about some fucking goddamn bizarre bullshit that you want to add to it because the sun has motion. The Earth doesn't give a fuck about the motion of the galaxy. The Earth gives a fuck about the motion of the sun. The sun is the gravity affecting the Earth, and if the sun moves, then the Earth will move. Okay, but the two, there's no connection between the Earth and any galactic influences in terms of relevancy. The sun is 99.999999999% of the influence, and the galaxy is 0.00000000000000001. So fuck you in this bullshit. So by this theory, like I said, you can't call a galaxy flat. So you see the point? He's just being an insane, psychotic, nitpicking lunatic. Only a lunatic would say galaxies aren't flat. Only a fucking asswipe lunatic would do that. So just go fuck off, Numbly. You're a waste of space and time. You truther kook. Yeah. All right, so now I will get to some more normal comments. Um, oh yeah, there was one other. I'm sorry, I saved it for later, so I might as well read it. Your claim that there is no divergence in the collimated light laser beam over long distances is wrong. So again, I never claimed that. All right, what I made is an argument, right? So this is my understanding of the history. We were talking about one of these raggy NASA experiments that are we can detect a human hair from 10,000 miles away, kind of bullshit, like the experiment he's going to cite here, which is funny. Uh, in another video, where he's defending NASA and their brilliant observation. Um, so anyway, so this whole comment is really irrelevant because I didn't make any claims about lasers. All I made was a claim that, well, look, they shoot lasers to the moon and back. See, it was Numbly's claim that the lasers spread out too much and there's no way NASA can communicate between two satellites that are whatever distance away with a laser. And I just pointed out, well, from my knowledge, they send a laser to the moon and back. Now, it is a very high-powered laser, and they shoot it into a reflector that's it's not a mirror. I said it was a mirror. It's not a mirror. It's a reflector, and it reflects at all angles. So basically, it doesn't reflect light very efficiently in the sense that it's reflecting light at all angles. So it's dispersing it. So the only light that comes back to the telescope is a tiny, tiny amount of what the laser shoots at the moon. But the point is, the laser goes to the moon and back, and it's a fact. And that does happen, and that was my argument. Okay. And so he's posting all this crap from some site, right? So it's all this, you just post crap from a Wikipedia site. Therefore, somehow he's proven something, and something I said was inaccurate. No, I didn't say anything that was grotesquely interacted. I said it was my impression. I said it was my understanding. That's what I said, jackass. I never claimed to be an expert on lasers. I just claimed to say that, from what I understand, lasers travel to the moon and back. So they can't be diverging that much. And this, he gives me a mathematical equation. And obviously the equation doesn't look like it disperses much. I mean, it's a tiny angle of dispersion. So anyway, especially for, as you go with higher wavelength lasers with larger apertures, that means wider beams, the dispersion gets less and less. So obviously NASA, I imagine, could make a high energy blue laser, with a wide aperture, and the beam will stay coherent for quite a distance, I would imagine. So again, just fuck you, asswipe. Ugh. I mean, it's, just the definition of a troll. Just fuck off. I have no interest in communicating with you in any manner. You don't have the balls to make a video on anything really relevant, like the general theory I've developed. And if you really think I'm wrong, go ahead and please make those videos, because I would love in the future to humiliate the motherfucking cunt shit out of you, you fucking troll. Because that's all you are now, is a nuisance fucking troll, and you're demonstrating it by your own hypocrisy. For 6 months, I was right about something, and all of a sudden I'm wrong because I don't buy into your truther psychology. You fucking psychotic lunatic. Shall I mean, post fuck you on my channel too. I mean, what the hell is that nonsense, you fucking infant? What are you, 15 years old, you little retard? Ugh, shit. Anyway. I mean, it's just... All right. So some asshole says, well, the real Miles... Oh, well, I'll read the other guys. Well, maybe it's still here. Yeah, so I don't have to... I think I saved it because it didn't show... the comments are so fucked up. Because, you reload the video and the comments change. I'm like, why the fuck has the comments changed? There's nothing in the spam folder. Why are comments disappearing and then they show up again later? I mean, YouTube sucks. So anyway, Mr. Keebler, will the real Miles please stand up? Well, that's not the subject of the video. I mean, I made it quite clear I have not made any claims about being Miles Mathis. I have done nothing inappropriate in using his name because he was posting physics articles. I referenced the physics articles. Yeah, the fact that we both have blonde hair really shouldn't confuse anybody but a complete motherfucking cunt idiot. So I really don't want to have a fucking conversation about this fucking bullshit. Anyway, let's see. All right, this Douglas guy left a couple of comments. I probably should do his older ones first. So maybe I will start back here somewhere. All right, let's see. All right, so here's the Morley experiment shit. All right, I thought I'd talk about the relativity. Okay, I did that one. Thanks for sharing your ideas. I want to debate against this guy. I just don't have the energy. I don't even know who you're talking to. See, I mean, that's another one of those things where somebody says something, you're just like, you have to make more articulate a comment. I want to debate against this guy. So I did a video to Hothliday and the camera guy, Ken. I don't know whether you're talking about me or them. Well, who are you talking about? I wanted to debate against this guy. What guy are you talking about? The guy I'm talking to in the video or me, you stupid idiot? But I just don't have the energy to argue with one who will not listen. I don't even know what that means, right? One who will not what? Obey? Yeah, fuck you. Make an argument or shut the fuck up. Jesus Christ. All right. All right. So there's the crazy guy with the conspiracy. I might as well delete his idiotic comment. But no, I mean, he has the reference to Miles Mathis's page there, so that's good. Because that's the nutty page, the Miles W. Mathis. That's the W stands for wacky. Because that's the page full of weird articles. I mean, I just had no idea. I guess this is one of the things gets him off or something. He likes to write, fiction articles, about how everything is a conspiracy. Anyway, if you are thinking photons are a wave field, interesting. Now, let's have to explain that guy. No, it's not waves. Some people can't, post their comments coherent to their first comment. It's irritating. All right, a photon. Okay, so this is the Douglas Harry guy. All right. Well, Harry Douglas, I guess, right? Burrell. Anyway, a photon may be pushed in the sense that it can exert pressure. That's not pushing. Exerting pressure is not pushing. Let's understand that first of all. You're not getting pushed when you're exerting pressure, and therefore experience an equal and opposite reaction. I mean, all right, in the sense that it can exert pressure and therefore experience an equal and opposite reaction. Well, again, it doesn't experience an equal and opposite reaction. Photons that are reflected are actually absorbed and readmitted. So the electron is experiencing, the photon isn't. The individual photon, in fact, actually did go straight through, and the only thing that was kept was the polarization. But that's a whole other subject. An electron experiences recoil when a photon leaves it again, suggesting a mutual push. Again, it doesn't suggest that. It just suggests that it had a fish that went in, and so now it's plus fish in. And then when the fish goes out, it's minus fish in, so now it has less momentum. So you lose what you give away. You can't have what you gave away. So if I have an extra fish, which makes me go forward, and I give away the extra fish, I can't go forward anymore, quite obviously. So you give back what you got, which is energy in, energy out. Agreed, it seems light cannot be pushed to go faster than c. Well, that's the point, right? Isn't that the point? Point is you can't if something's going the speed of light, you can't possibly push it because you can't move anything faster than it. That's the point. But from a higher energy source, the speed limit appears to cause photons to bank up, so you get more passing per second, i.e. higher frequency. Well, frankly, you don't. That you only get higher through a medium. So first you have to slow the photons down, technically, by creating a greater distance for them to travel. So like in glass, the photons aren't traveling a straight line. They're weaving through the electrons, which is creating a longer path, which means it takes them longer to get through the medium. Now, the shortcut is if the photons are as represented in an electron, if they move an electron, the electron doesn't weave. So the electron can go straight and then release the photons. And that method of transportation is faster than the individual photon weaving through the footpath. So it's kind of just comparing like a road to a footpath, and the footpath has weaves in it. So if you walk as a single photon, it'll take you longer. You'll walk more distance. than as if you took the expressway. But the expressway is not going faster than the speed of light. It's actually going slower than the speed of light, but it's faster than the photon through the medium. So it's not going faster than C. It's going faster, C in empty space is going faster than C in glass. So instead of slowing the photon by 40%, it'll only slow it by 20%, but it's still slower than the speed of light in a vacuum. I mean, that misimpression is just a byproduct of the bad press. I mean, the press can't do these stories accurately. The science community does deceptive because it has some headline that says something like faster than light. And it's not faster than light in a vacuum. It's faster than light in a medium. All right, anyway, does this mean that photons are fixed from the source at greater energy and speed greater than c, but then are brought back to the speed limit like cars in traffic? No, it just means that photons are slower in a medium, and so therefore you can go faster than a photon in a medium because the photons are going 40% slower than normal, in the sense that they're traveling 40% more distance. If your bullet analogy holds true, then I guess the photons are just being produced more frequently and not more rapidly. Now that's interesting. From the source. I mean, I don't know how you can do that. Just being produced more frequently and not more rapidly. They don't go faster. That's right. They have one speed and one speed only, and you can have more of them smashed together if they're of a narrower frequency. Yes, from the source, like the machine gun compared to the pistol, but that would mean each photon is not energetic than a lower frequency photon. That's right. The photons themselves, the quanta, 2 per photon. The quanta have exactly the same energy in blue light and red light. The only thing that blue light permits is for you to cram more energy in the same space because they are more tightly bundled. But if you only fire 2 bullets out of a machine gun or 2 bullets out of a handgun, that energy will be the same. But the point is obviously the machine gun can fire more bullets in the same amount of time. So if you need more energy, you can produce more energy with blue light, but it's not automatically more energetic. It's just potentially more energetic. It's only a potential. Doesn't mean you have to realize the potential, but yes, blue light is potentially more energetic because you can shove more of it in the smaller space. All right. But would that mean that each photon is more energetic at a lower frequency? No. Amplitude may relate to caliber of bullet. Now, there's no calibers. All the bullets are exactly the same. The only thing you can change is how many in a period of time. If you could push photons faster, you might get constructive interference like double amplitude when they stack. You can't stack photons, but with no change in frequency. Well, you can't do any of that. Even if you had even if you could take 2 beams of light, rays of light, and place them right on top of each other, they have no impact because they're still going to be staggered by a different distance, and there still could be other quanta in between. It just has no. The rubber bullets are still in between, so to speak, the gravitons and all that stuff. It's only really polarization that is the marker. So a photon is really identified as a stream of quanta with markers of polarization at specific rigid distances from each other. That's what constitutes a photon. So there can be lots of quanta in a stream, but there's always lots of quanta. That's the whole point. You're surrounded by it every second of your existence, and there's a ton of energy pushing you together all the time. You just don't see. Amplitude may relate to caliber. If you could push photons, you might get through that's interference and this change in frequency. Some suggest that photon stacking creates matter. Well, again, I don't believe there's stacking, so I don't think that really is relevant. But whatever. Thanks for the usual interesting discussion, food for thought. Oakley doke. You're not stacking tons. You're not stacking. And again, the point is that, well, I'll get to it when I get to this, but I mean, it's polarization is really all that matter identifies. So you can only affect matter with a stream that is of polarization. Electrons are really only influenced in the sense of gain acceleration. Okay, no, I can't say that because gravity does affect them, but they can't absorb permanent. No, okay, not permanent velocity. Yeah, the force. Gravity has to always be there, right, for gravity to work, right? So gravity is a constant imbalance. The Earth is creating an imbalance. The external world, it's a constant thing, and that's why the acceleration is permanent, which can make it a permanent velocity in a sense. But for electrons to gain velocity, they have to actually absorb photons. They can't really gain velocity from gravity, gravitons, quanta. But I don't want to get into it. It has to be polarized to be truly eaten by the matter. For the matter to truly absorb a force, it has to, the force, absorb it in the sense of it becomes a permanent velocity. It has to absorb the polarization of the force. Okay. The bits that are polarized have to transfer their polarization. That's what's being transferred is polarization. All right, anyway, Terrence Kinsey. A few months ago, a neighbor emailed me a link to Miles Mathis' website. After clicking the links, I can't remember which one specifically, I ended up watching a video of you. Well, that's bizarre because I don't think he has any links to me on his page. So that doesn't make a whole lot of sense. But maybe he did a Google search. I don't know. I really don't think he has a link to me anywhere on his website. I don't think he ever, I think kind of obviously he has no knowledge of me, even though I did email him. You know, I do have the email somewhere. I mean, I was basically just giving an opportunity to be, you know, for us to collaborate on our effort to demonstrate that conventional physics is full of shit. And, you know, in hindsight, I'm glad that he pronounced his desire to be a lone creator. And because, yes, I wouldn't want to have to try to explain how my partner is insane. So, yeah, that's good. All right, so mindless marbles. Okay. Okay, apologies. You know, I got to make sure no one's fucking with yeah, things. Let me just see. Where's the comment section? Oh, bye-bye. Yeah. Oh, we'll see you soon. I'm not known with that. I'm nice. Okay, we'll just block that guy. Hi, I'm a nice guy. Yeah, that sounds like somebody looking to make trouble. Well, that's worth blocking. All right. Keep your eye on that kind of stuff, you know. So much to do. So few me's to do it. Okay, apologies if I misinterpreted part of the video, but it needs to be discussed. We need to be extremely clear where we agree and disagree. All right. All right, so this is on the speed of light and understanding what the Michelson-Morley experiment could demonstrate. My argument about the Michelson-Morley experiment is it's not an experiment done at any of these speeds of these thought experiments, so it's not relevant to the thought experiments about how light could be perceived if you were moving at some incredible speed. So it's not happening at those speeds, it's happening at minor earthly speeds, and it's really looking for drag in the ether. And the argument is that you're not going to find drag in the ether because quite obviously there's no drag in the ether. Quite obviously light travels through the ether unencumbered, or it couldn't travel billions of light years to get here. So there's obviously no drag from the ether. So a drag experiment doesn't have much relevancy, in my opinion, to answering any of these questions about what happens when you start accelerating to preposterously high speeds and your matter starts stretching and your whole formation of your function changes dramatically. including the ability of your electrons to absorb energy. Okay. At some point in the video, you say that light does not gain speed because the photons are released, not pushed. Let's be clear that almost everyone agrees with that. I would say that no, you're wrong. Okay, because basic physics still doesn't explain what photons do. They don't concede that they're part of matter, and they certainly don't understand them as being um, that all interactions, in a sense, force on force. It doesn't matter what your velocity is. So if I have a school of fish, and the fish are only capable of traveling c, a constant speed. They don't travel anything else. So let's just change c to 5 miles an hour. So you have a school of fish. The fish can only travel a maximum of 5 miles an hour. They can't travel anything slower. And so clearly, which way the school moves is going to be dictated by how many fish are spending how much time pointed in a direction, right? So that's going to be the entire definition of the motion of the school overall. And you just make a rule about the fact that the fish can't just leave the school. So I don't want to explain all those dynamics, but I'm just saying let's have just a rule that they can't leave the school. So when they reach one end, they have to turn, and then they have to go the other way. But the point would be they have to spend more time in one direction. So that means they have to go this way longer, and then the school moves, and then they go a shorter distance back and a longer distance, that kind of thing. And then all interactions with force are always at the speed of light. If two fish are colliding, they're always going to be colliding at the same exact speeds. All accidents happen at exactly the same speed. So all interactions are technically, it just doesn't matter whether you have velocity or not. The only thing velocity will tell you is whether you're going to have more interactions that are intersections, where something going up and down hits something going left and right, or this way and this way, or whether they're head-on collisions. So the only thing you're changing is what type of interaction the force can have. But you can't change the speed of the interactions, just the type. That's the underlying physics here. So I know that's certainly not what conventional physics understands. Not everyone agrees with that. Okay, that statement. So that's all I'm saying is they don't get that. That momentum doesn't, the momentum of the school is irrelevant to the momentum of the individual fish. The individual fish are not moving additively with the school. Because I'm a fish going 5 miles an hour and the school is going 2 miles an hour, I can't assume to be going 7 miles an hour at any point. I have to be moving through the school at those points, not moving ahead of the school. I can't go faster than 5 miles an hour. All right. However, all else equal, that's precisely why people would expect the Michelson-Morley experiment to return a positive result in that case. I don't know exactly what you meant by that, but my point is that all it's really, it's asking a question I think that was already kind of obviously already answered, is that there clearly isn't any drag, okay, from any ether on anything that we even knew of. So there was no obvious drag. So why would they expect to find drag? Because it doesn't exist. And they're not doing a high-speed experiment. They're doing a low-speed experiment. So I'm just saying they're not going to be able to get to the fish because their experiment is happening much too slowly to be relevant, to be able to find the subtle differences that are going to take place when you start moving at very high speeds. All right. If I am moving to the right at a speed of half of the speed of light, and I flash my flashlight to the right, that means ahead of me, and the light will get ahead of me by only the rate of 1/2 c. And yes, but you can't, number one, you don't see light, so you can't see it doing that. You can only perceive light over time and based on markers that it might travel to. So you could have flags ahead of us, and you could say, okay, the light has reached a certain flag, and I know that flag is a certain distance. And you will be sitting here saying to yourself, if you're moving half the speed of light, you're going to perceive that light to be getting to those flags too quickly. Let me think. You release the light. You're going to gain distance on the light. No, it's going to reach the flags at the right time, perceptually. But you're just saying that somehow you're going to see the flag as being closer. So how you see the flag is kind of irrelevant to the question of how long it took the light to get to the flag. So the time it's going to take the light to get to the flag is going to remain the same for the distance away from it you were when you released the light. So that the time you release the light, the amount of time it's going to take for the light to get to the flag is going to remain exactly the same. And the fact that you are getting closer to the flag is going to be quite obvious that you're getting closer to the flag because the flag is going to get bigger, 4 times bigger. So, I mean, it's going to be obvious to you that you're moving. So I'm just saying there'll be no deception that this is somehow something weird, like the light's not moving fast enough. I'm just saying you can't see the light moving. So I'm just saying there's no way for you to perceive that except as a timed equation. So I don't see how it could possibly be relevant. The only thing that, like I said, it's the light coming at you. You have to use something where I guess you have to interact with it, but then it becomes a metabolism question. We're broken again because I'm going to argue you don't have the metabolism capable of measuring it accurately. All right, well, anyway. If I am moving to the right at speed of half c and a flash, you say at about, okay, this means that I, the moving guy, will measure the speed to be going away from me at half c. Again, you won't measure it at half c as a time equation. As a distance equation, yeah, it's going to look like it got there twice as fast, because the distance isn't going to be the same distance, but the distance isn't the same distance. Let me see. You know, obviously, by the time it hits, you're going to be twice as close to the target. So yeah, so yeah, you can't watch a photon moving, so this question becomes irrelevant. And if you could watch it move inch by inch by inch by inch, then yes, you would notice that the light is moving smaller inches. But clearly you'd also be able to quite obviously see that because you're moving towards the target also. So that just makes sense. I mean, maybe this is better done with like track runners, like you're running with somebody and they're running twice as fast as you. And so as you saw them getting away from you, your expectation is that they should be running another factor faster. So you're measuring them not going fast enough and escaping you, by what your expectation is at their normal speed. So if you're standing still at the starting line and you stay still and you just have somebody run, they're going to get away from you much quicker than if you're also running half as fast as they are. So if you run half as fast as they are, they'll get away from you much slower. So they'll appear to be moving slower. But I'm just saying you're going to be quite aware of the fact that you're running. So clearly the light isn't going to change. The other runner doesn't change. He's doing exactly the same thing in both scenarios. He's moving at exactly the same speed. The only thing that's changing is you're moving the position of your camera, and then arguing that a moving camera should somehow be the same as a stationary camera, and that would be a silly expectation. Okay. Sure, you can say my tools are broken. Yes, your perception is broken because it's moving, just like my clock. But let's acknowledge that my shitty tools will measure half c for light going to the right. But again, you can't do the measurement while moving. If you're doing the measurement while moving, it's not a measurement of his speed. It's a measurement of your combined net speed. So just acknowledge what you're measuring. You're measuring a net perception of distance, not the actual speed that something's moving. So if you're moving the ruler, obviously the ruler is going to read wrong. So if I take a regular 12-inch ruler and I move it as I'm measuring something, I'm not going to measure it accurately, am I? So you can't move the ruler. So that's really what we're talking about here, is if you're going to talk about how fast something's moving, the ruler can't be moving. There, okay, that explains it. Similarly, if I mean, it's like that's having like the markers on the track. So let's see, we have marks on the track for a specific distance. And so then you can see how long it takes somebody to pass those marks. We're almost arguing that if I allow you to have a moving ruler, that's like allowing the lines on the track to be moved. And if you move the lines on the track, obviously the runner's going to look like he's going a different speed. So obviously you can't move the reference points. So the reference has to be from a static position, not a moving position. You can't do measurements while you're moving. That's intrinsically, fundamentally going to create a mismeasurement. Okay. All right, I like that. All right, sure, you can say the tools are broken, just like my clock, but let's acknowledge that my shitty tools will measure half C for light going to the right. Again, you will perceive the guy going slower because you're moving so much faster. But yes, it's really an obvious mistaken perception to assume he's going slower because you're going faster. That would be stupid not to recognize. Similarly, if I'm moving to the right again, half speed, and shine a light to the left, I would measure, same shitty tools, that light is going to the left at 1.5 C. And yes, you would, but obviously that light isn't. You're just, again, moving the ruler, so you're exaggerating the perception of its movement. So again, it's just a bad measurement. This is the vital point. Okay, should Michelson-Morley experiment notice that apparent, emphasis on apparent, discrepancy in the speed of light? Well, again, what I'm saying is that the Michelson-Morley experiment isn't being done at the speeds necessary to recognize this flaw. So that Michelson-Morley is like moving the ruler, a zillionth of a millimeter. It's moving the ruler so little that it can't possibly detect the perceptual difference between the two runners. It's too small a movement relative to the speed of light. So, and that's the important speed. See, they're thinking in terms of the speed of the planet spinning or something. That's not enough speed relevant to the speed of light. So all they're really trying to detect is drag. They're not talking about relativistic time dilation. It's really an experiment that can only pick up drag. Similarly, if I'm moving and it's drag on all photons all the time, which, again, nobody would be arguing that photons experience drag in space. Similarly, if I'm moving to the right again at half C speed and I shine my light to the left, would I measure? Yes. Okay, this is the vital point. Sorry, I don't know why I picked up at the wrong location. Apparent emphasis, discrepancy in the speed of light. We are moving through an absolute frame, so we should detect that asymmetry. Well, again, you're not moving through an absolute frame. You're moving the frame. You're moving the ruler. So again, you can't move the ruler and then expect to take accurate measurements. Since we're moving through an absolute frame, the interferometer would be considered a shitty tool that would show you the discrepancy. Well, again, I'm just saying that that's all fine and good if you were using the interferometer going half the speed of light, but going 20 miles an hour isn't going to collect enough discrepancy to be relevant to this conversation. And I would especially make the argument that the effects of time dilation in terms of the effects on material metabolism, the ruler being broken effect, doesn't happen at very small movements because your matter still has integrity. The effects of distortion of the ruler only starts to really stretch when you start getting rid of the tangential dimensions of the matter and you start stretching the matter. So it doesn't stretch from the first 2 feet an hour kind of motion. It has to be a much, you have to start truly stretching, compressing the matter before, so you have to have a velocity sufficient to start causing serious compression. And I don't know what exact point that would be, but it might be something like 2% of the absolute speed. So you have to get up to at least 2% of the speed of light before you could have measurable stretching deformation of the ruler. How would you clarify these points? Well, that's how I'd clarify them. What am I getting wrong? I don't know if you're getting anything wrong. It is complicated, but again, if you understand that what you're perceiving has nothing to do with the interactions themselves, like I said, it's fish on fish, and we get confused because we think of school on school, and school on school isn't happening in real physics. Real physics is always fish on fish. So real physics is always quanta on quanta. There are no, my matter doesn't interact with your matter, my physical skin. It's always going to be the quanta on the surface of my skin that will influence you. Or I can't make force without, it's always going to be a phenomenon of the quanta that I'm made of, not the body that we see. What we see isn't what we are. Okay, that might be another way to say it. We can see schools. We can't see the fish. But the fish are doing all the fighting. Maybe war would be an example. Like you could, if you had a huge overview of war, you could see stuff blowing up and you could see stuff disappearing and see stuff on fire. You could see, but you wouldn't see the little soldiers doing all the, making all that stuff happen. Yeah, it might be a good way to say it. All right, so let me see if that's the same comment I saved here. Yeah, okay, so I don't have to worry about that. I saved just in case it got destroyed somehow because I didn't see it showing up anywhere. All right, one more to go. Just check the chat thing. Let's see, I understand none of this. I have no idea why I listen to DraftScience. Well, if you have no idea, you don't, I really don't need that comment, buddy. So, pretentious idiot. Yeah, your name fits. So I will block you to do you the favor of never coming back. So fuck off, asshole. God, you're just so brilliant. Just, human beings are just such scum. I am just saying, the evidence seems overwhelming that most human beings are scum. Stupid scum. Anyway. Jesus. Anyway, Douglas, you are a gifted and highly entertaining communicator, putting it all out there. Well, okay, I don't need that crap, but your touch analogy raises interesting questions. If the touch had the energy to pump out photons in the forward direction while you're traveling at the speed c, Einstein's speed limit would cause extreme blue shift to a frequency such that photons would stack. Well, again, I don't buy this stack argument. And you could reach out and grab them. Well, I'm sorry, that just can't happen, okay? You can't reach out and grab a photon. They don't stack. They don't slow down. That's their distance. Distance and time can't be bent. So Einstein's crap is crap. There's no bending. I don't bend the universe and then reach across it, okay, to grab something. Just can't happen, okay? Distance and time are functions that happen in the 3 dimensions. They're not a separate dimension. If you shone a torch backwards, you could, a torch is this, that's kind of a light. If you shone a torch backwards, you would get extreme redshift, 0 frequency. Well, if it's 0 frequency, you don't have anything. You don't have something shifted. You have something annihilated. But anyway, and a trail of stationary photons relative to the photons traveling alongside you at speed c. Well, that can't happen. There's no such thing as a stationary photon, nor uh, photons traveling alongside me. So again, you're taking this material example and you're not recognizing that you can't move matter the speed of light, okay? Matter can't do it. It can't sit on a photon train. It can't do it. It's a photon if it's going the speed of light. That's what it is. It's a photon. It's not matter. Matter by definition, the school can't go faster than the fish. The school can't go as fast as the fish, right? I mean, the only way you can have the school go as fast as the fish is all the fish have to be going one way, and that's a laser beam, right? So I'm just saying that matter can't possibly, by definition, go anything close to the speed of light and be called matter. Well, anyway, some theorize that the edge of the universe is traveling away from us so fast that light from there can't reach us. Well, again, this is, I don't know if I really want to get into this, what's at the end of the universe thing, but I would argue that their gravity might weaken. Okay, that the bubble of gravity, and once you go outside the bubble, there's no gravity and everything just flies into nothing, little photons shooting forever in a direction. Something does not add up with relativity. Well, that's a sentence, but I don't know if it's an argument. Resound, do you propose that sound can only be produced by exceeding the speed of sound in order to perturb waves that already exist? No, there's no already existing wave in sound. Sound's about molecules moving. Well, you do say that. Okay. Already exist. The molecules are already vibrating randomly at the speed and energy as in Brownian motion. Well, obviously, that's not a coherent movement. That's the Brownian motion. And what I'm saying is you have to exceed the Brownian motion in a sense. You have to be able to make the sound transmit. You have to, it's like the domino thing. Moving the domino halfway, doing this with a domino. Let's say dominoes were magnetic. And I move the domino halfway. You could sort of see that going halfway, if the other dominoes could absorb that without falling, they would just do that. They would absorb it and then go back to their neutral position. So I didn't go far enough to tip the dominoes. So really all I'm saying is you have to exceed the speed of sound to create the vibration that goes through the wave to tip the domino. You have to tip it. And the only way you can tip it is you have to hit hard enough to create enough force to push it over the edge. Okay, the momentum edge. Or it gets dampened. It spreads linear sideways instead of forward. So if I push slowly, it's like pushing into skin slowly, the force spreads. But if I did it really quick, I could make a hole. If I did it quick enough, because there'd be no time for the force to spread over my skin. I'm doing, skin poking. So if I poke it slow, the skin has time to stretch and pull sideways. But if I go fast enough, the same amount of force will poke a hole. Okay, because nothing will be able to stretch. There'll be no time. And so all the force goes forward through. So that's the argument. And that's why sound has to be spread that way, because it has to overcome all the random motion to create a solid kinetic interaction, so to speak, a solid transfer of a complete position change. So it's like, instead of dominoes flipping, it's like magnets pushing. So it's like I push a magnet and it pushes the forward magnet, pushes. But if I push slowly, then all the magnets just misalign. So if I push the magnet really quickly, then all the magnets will move straight. But if I push the magnet really slowly, all the other magnets will just realign crooked. And that's how it will absorb the energy. So the energy can only really be transferred if I go quick. That's the argument. All right. If you're shown the torch backwards, reach out and grab them. Yeah, that's the stacking part. Okay, I'm on the sound part. Okay. Let's see, molecules vibrating in the matter may be mediated by EM forces. Okay, here we go. Brownian motion, or that matter to matter contact may be mediated by EM forces traveling at speed c. Well, again, I'm saying they're going to get dampened. If there's slow forces, slow force gets dampened, fast force doesn't. It takes time to dampen energy. You won't dampen it if it's at a high frequency, so to speak, if the impulse is quick. So the impulse is quick, then the energy won't be dampened. But the gap between, whatever, tiger, cat, yeah, what are you popping in the room for, buddy? What are you up to? Huh? Go ahead, mute me, do whatever you're going to do, and then I'll appropriately react. You have some agenda. Oh, I don't have my sound on. Maybe he's talking. Oh, okay, let's see. Are you talking? No, it's not talking. Are you going to talk? I don't hear anything. Ah, he left. And he didn't mute me. That's interesting. It's usually their purpose is to cause trouble. I'll have to see if he's in the chat. That's right, the chat thing. Okay, so I have to wait. Yeah, you can't block anybody out of that stupid chat, though. It's not very useful. I hate this. I mean, this whole video thing is really quite nice that you can do this live broadcast thing, and just to have these idiotic inane tools to create a little bit of security for your own room. It just is just so irritating that Google can't provide that minimum of like giving me the power to control the room rather than giving the trolls the power to control the room. I mean, that's just so fucking stupid. From a company that's supposed to be full of fucking goddamn, high IQers. Yeah, well, they look pretty fucking stupid to me. Anyway, got a real problem with the vision thing at Google. All right, let's get back to the finishing here. We're almost done. All right. EM force is traveling at c, but the gap between the molecules in the gas means that each molecule must travel a certain distance before relaying the energy to the next. Yes. Sound travels faster the more solid the medium. Well, obviously, yes. The distance is shorter and the capacity to dampen is less real. The capacity for the molecules to go somewhere sideways is less viable. In your favor, we hear a collision between cars traveling at sub-sound speeds, but it is the release of kinetic energy. Well, the sound is the byproduct of the parts flying off faster than the speed of sound. So it's what you're hearing is the acceleration of the matter of the pieces that are being thrown through what do you call those? Centrifugal forces. So they're spinning off, and through that spinning off process, they move faster than the speed of sound. So even though the part's leaving at maybe 70 miles an hour, the fact that it's rotating means it's going much faster at its ends. So those pieces of matter are going faster than the speed of sound, and therefore they're the ones breaking the sound barrier and making the sounds. And obviously in the initial collision, what you're hearing is the air that is being compressed and then shoots out really fast from the impact. But a release of kinetic energy, which at the fundamental level would be EM at speed c. Well, again, it's matter. It's matter accelerating. And it's not going the speed of light. It's just matter accelerating above the speed of sound. Again, we're talking about sound waves being perpetrated through the atmospheric medium. So we're not talking really about physics. We're talking about mechanics. Anyway, initiates the transfer to vibration of air molecules. The break on speed then becomes the distance between the atom's molecules in whatever medium, right? We should be able to hear the collision much sooner at light speed with a suitable EM detector. Regards. I don't know what that means, so I won't even bother with that part. Yeah, I don't know what the hell that meant. I do not understand. All right, so I think I did my job there. Yeah, still seeking somebody willing to defend conventional physics. Two-slit, Heisenberg, Huygens, any of that rubbish. So I was just laughing because now Numbly Numb is going to be a defender of conventional physics. It's kind of funny. An asshole. Oh, it's so disappointing. People, petty little weasels. What else? Anything else? Yeah, I don't think I need to beat this one to death. I really do. I think I will play more of these lectures from the lecture thing, the Gravity Guy videos, because I think they are very good for as a platform of here's what we say, and then you can make your counter argument to why what they're saying is crap, and it's just spelled out really nice, and it's not slowed down by getting into all the mathematics. It's just about the statement, about the relationship, not the specific mathematical relationship, but just the physical, factual relationship, which I think is more, math is important, but it really isn't physics. Physics is understanding the relationship between things, not just as a static fractional equation, but understanding it as a it's like you can't like mathematically draw the idea of fish and school and understand that schools aren't interacting, the fish inside the school are interacting. You can't draw a mathematical equation that explains that the fish, the school is an expression of the fish, not the other way around. The fish aren't owned by the school. The fish make the school. That kind of thing. All right, so I guess I won't linger unless there's somebody who wishes to discuss physics, capable of doing it and all that shit. Yeah, you really have to be kind of capable. Then there's no real point if you're not capable. And it doesn't seem like there's anybody capable. And there's nothing in the chat. So I'll let it go at that. And make more videos and do less of this, I suppose. I don't know. I'll have to, we'll see. I mean, this is good enough for doing comments, and it's good enough for when I'm doing, maybe when I'm doing thought experiments on subjects a little less complicated than the part I'm on right now. I mean, the part I'm on right now is the real nuts and bolts of the polarization argument and how it's fundamental to the function of gravity, magnetism, electricity, and the formation of matter itself. So it's so this will be I think I'm going to make this my new icon. I think it's a little lopsided, and this one's less lopsided, but it's also less perfect. I mean, it's too pointy at the sides. So it is funny that I can't seem to quite draw it right. I mean, that one's probably straighter, but this one's friendlier, I think. So I'll probably go with this one. Maybe if I turn it this way. Yes, it looks more lopsided that way. It looks less lopsided that way. But anyway. But that's kind of a representation of maybe an electron. That's sort of how electrons function. And since they roll in the 3 dimensions with very hard elements, so their elements are they're perpendicular elements. Every element is, every one of these rings, the other 2 rings are exactly perpendicular to any one of the rings, kind of a thing. So that sort of explains, if you think about in those terms, if it was made out of flat things in the 3 dimensions, that those flat things will all have polarization, and that would be consistent. And that when you expand one ring, you reduce the other ring. So you automatically, if you make one ring bigger, the other ring loses fish. And that might really just be happening at these nodes. There's 6 nodes where 2 dimensions intersect. So, and only 2. So there's no point where all 3 dimensions intersect, but there's lots of points where 2 of the dimensions intersect. And those switching of those points, like say blue owns these 2 nodes, and then they switch to being owned by red. That's kind of an interesting switch. And that might be what some of this is about. I'm just saying that's why this is an interesting, there's a lot happening in this very simple diagram, in a sense that you can explain a lot of, especially with color, what's happening with electrons and their spins. But anyway, I don't want, like I said, that's for a future video where I will attempt to explain some of this stuff. And the stuff I'm going to explain isn't even that stuff, it's this stuff. But this stuff is like this. The underlying function is really simple, but it's one of those things where if you don't know the secret, it's not simple. It's not simple to, I mean, I could say the words, like I said, I could say the only thing that makes me, the only thing that makes matter is consistency, is an imbalance in polarization, a collection of polarization, orientation, shape of quanta. And that's the only thing that's being filtered out of the field. So all the movement of the quanta itself, nothing changes. It's all just moves in straight line vectors. And the only thing changed is the color, so to speak. You can catch color in circles, but you can't actually collect quanta, just the color. And see that on the surface, that doesn't sound like anything, but it does when you really go through it. Yeah. And once you see it, like I said, once I drew it out, you can see how polarization does all of this. But you really have to think about it and understand the difference between this kind of collision, right, where green pencil always goes through blue pencil and blue pencil always goes through green pencil, right, no exchange, and this interaction where blue pencil goes this way and green pencil goes that way. Change direction. Green was supposed to go this way, and blue was supposed to go this way, but it didn't. And that's the big one. Anyway, so that's what I mean by collecting. All right, so till the next time, and such, and so forth and whatnot. Yeah. And hopefully I can drag somebody in here to make conversation and whatnot now and then. But it has to be somebody who, I need somebody who's, knows physics and doesn't just go to Wikipedia page. Yeah. Anyway, till next time, such, so forth and whatnot. Stop broadcast. That's what I'll do.